So we're going to do what I call the OLED Hellow World. So can you all see my screen okay? Do I need to make the text any bigger?
It looks good to me.
Because I
Yeah,
think I can
a
actually.
little bit bigger would be good, Jim.
Okay. How's that?
Well, if he's on a tablet, that's
I'm
good.
on his tablet, but it looks good to me.
Okay. All right. So let's start out by going to the platform.ini file. And again, what I did, we'll walk through the steps on how I created the project. So I clicked on the little platform IO icon over here on the side, and then I go down to open under PIO home. And then I came up here and clicked on new project, and then I gave it a name, OLED Hello World. And then we're going to select the board we're using. And so we're going to type in we're looking for ESP32 dev module. And then and we're going to use the Arduino network. And then in my case, I've actually taken and put this in a different location. You can use the default location, like I said, which is going to go into your projects folder, which is actually under your documents platform IO, or you can put it in another one. Like I have mine in another folder where the source code is source code repository is going. But and then once you're done with that, then you can click on finish and it'll create your project for you. Then the first thing we're going to do is we're going to go add a couple of libraries, because we don't want to have to write this display code from scratch. And so like I always say, we're going to stand on the shoulders of giants, and we're going to let me find my project here. We're gonna look for the Adafruit GFX library, and we're going to install that. And then we're going to look for the Adafruit SSD 1306 library and add that to our project. And by default, because the SSD 1306 uses the I2C library, they include this Adafruit Bus IO library, so that they can use their own I2C library. So let me switch back over here to the source code. And the other way you can see where everything is you can look in the platform IO any file. And you can see the environment for the ESP32 dev module. The platform is Expressive32. The board is ESP32 dev. Our framework is Arduino. The monitor speed, like I said last week, is something that I add so that I default the terminal always to 115K baud. If you don't, then it'll default to 9600 baud. It's not a big deal, but it's just something that I've gotten used to doing. And then the libdeps is basically a list of all the libraries that we've included in it. So now let's go look at the main file. So,
hey Jim, quick question.
Yes, sure.
I've been playing a little catch up from the last session, and I noticed that I got an error that it was looking for the wire library. I'm not sure if you covered that last time or if that's just a unique problem I've
got. Well, actually by default, wire should actually be added, but it may not. Let's see, because it should actually be part of the framework. As you see here, where it says framework-Arduino Expressive32,
right?
Libraries wire, it should be there by default.
Okay, I just didn't know if anyone else would run into that. I ended up fixing it by adding it to the platform IO any file.
Yeah, well, that'll work. That'll work as well. Yeah.
Okay,
but
cool.
it should have brought it in. You might want to double check and make back on your platform any file, and make sure like it looks similar to this. Because what'll happen? Did you pull the source code from GitHub, or did you just go through it?
Yeah,
Right?
I just did it. Actually, I just did a copy and paste.
Okay. Well, you might look at your platform ini file and see if it matches what was in the source code.
Okay, no worries. Yeah, I think it did. I'm suspecting it's because I'm a Mac. Maybe there's a difference there, but just wanted to
Oh,
call
there
that.
may be. I
Mm.
I didn't think of that.
I could be your Mac test case, I guess.
Yeah, well, and I think Arnav is doing everything on Linux. So
Cool.
Huh.
We should have it all covered then. We need somebody on
Yeah.
a Commodore 64, right?
yeah, that's what we need. Let's not go down that rabbit hole. I can tell you about all the computers I've had since I was a wee kid in the late 70s. All right, so let's go through what we're doing here. So at the beginning of our file, we're including the header files for the wire library, which is what is used for the I/O, for the I2C interface. And then we're bringing in the Adafruit graphics header for the Adafruit GFX library, and then the definitions for the Adafruit SSD 1306 OLED display library. Then we need to come up with some definitions of what our screen size is, and this is used to actually initialize the display. So these are actually 128 pixels by 64 pixels. So there's so we define those, and then we're going to turn around and we're going to declare the display type by calling this command display and send in the screen width, the screen height, and this wire object, which is the I2C interface, and then a -1, and I can't remember what that was for. Let's see here. I think that is if it's connected directly to power or not. Well, matter of fact, let's go find out. So I just right clicked on that and I'm going to say go to definition. So it's going to go through and it's going to try to find that for us. And then it brings up it. So it's like, okay, let's click on that so we can see it. Oh, that was not the one I wanted. Let's go to the declaration then. Maybe that'll do it. Looking for. That doesn't help either. Okay. Well, let's try going to the definition of this guy. There we go. Okay, clock after. So that's not the one we're using. Let's see if there's a display. Okay, so we're using your data clock pin, your reset pin, and let's see. No, that doesn't really help at all either. Oh, it's interesting. It looks like they've changed it. Because I would have thought that display would have been this guy here, but I guess it's one of these here. Oh, those are deprecated constructors. I don't see a definition that takes 4 items. Everything looks like it takes 6. So I'll research that and I can give you what that -1 is all about. I'll respond out in the group's IO. Okay, and then last time we talked about the structure for the basic Arduino program. You have a setup function and a loop function. So we're doing all this in the setup function. So the first thing we're going to do is we're going to set up the serial monitor and get it started by calling serial begin with the baud rate. And then we're going to say if display.begin with the library and the address. If it doesn't come back successful, then we're going to basically just print an error message that we couldn't talk to that device. If it succeeds, then we're going to delay for 2 seconds. And this delay command, this is actually in milliseconds. So if you want to do 2 seconds, you got to multiply it by 1,000 to get 2 seconds. Then what we're going to do is we're going to start off by clearing the display. So that's going to wipe the display blank. And then we're going to set the text size. Now there are 3 different text sizes. There's one which is 6 pixels in the x-axis by 8 pixels in the y-axis. And then 2 is 12 by 16 and 3 is 18 by 24. So if anybody that had done any type of programming back in the old days before, you know, and you had to do that the old way, this basically, we'd set the size in the library to say, I want to use characters of this size, and then it's got all the fonts and everything in the library automatically for you, so you don't have to sit there and draw out each one of the characters. But that also helps the library determine that when you do a print line, it knows it goes down to starting on line number 9 to draw the next line of characters if we got a text size of 1. And then we're going to set the text color to white. These are only single color displays, so you can get OLED displays that have multiple colors, but for what we're doing, we're just doing a single color, so it's white. I think you can do an inverse as well, so you can have the background white with the fonts black. And then we're going to set the cursor position. We're going to basically move down 10 pixels, and that's where the cursor is going to start drawing out its text when we display it. And then our next lines is we're going to just print 3 lines that is going to be displayed on the screen. It's going to say welcome to, and then down the SI 5351, and then the next line is going to say rabbit hole. And then in order to get the display to update that, we're going to call display, a display.display. And that's going to then paint the screen. So what I'm going to do now is I'm going to plug in my 5351. And I am going to, so you can just, if you're just checking to see if your code builds, you can just do a platform IO build. But if you wanted to build and upload it, you can just hit the upload button. And if you watch my terminal down here, I'm going to bring this up a little bit higher so you guys can see it. I'll go ahead and I'll click upload. And I got to pick my workspace. Not now. Never. And so that's going to compile the libraries and everything together. And then we're going to start getting the little connecting, and I'll go over here and I'll press the boot button. And once I do that and it resets, then it starts uploading the firmware. And then while that's doing that thing and it says it's done, I'm going to switch over here to the overhead view. And you should now see the screen displaying welcome to the SI 5351 down the rabbit hole, or down the SI 5351 rabbit hole. I think it's flashing kind of bad, but you can see we got a display now. So if I come down and I change that, I can go in here and change the text and say, well, let's do this. I'm going to just play with this a little bit. And we're just going to, I'm going to comment out a couple lines here. Let me switch back over to VS Code. So we got it working. We can send stuff to it. What I'm going to do now is I'm going to comment out these, and we're going to change the text size to 2 so you can see a different size text. And so I'll compile and upload that. Oh. And then once it boots, go ahead, Bill.
So this is all Linux based, correct?
No, I'm actually doing this on Windows.
Really?
Yes.
And I Googled it and it said it can do all kinds of different iOSs, but all right. Okay, thank you.
Yeah, everything I've done is on Windows. So now you should see that it now says rabbit hole and the text wraps, and it's bigger now because I used 3. But yeah, Bill, the Visual Code will run on Windows, Linux, Mac. basically are covering Windows because a lot of people have Windows, but if you have a Macintosh or you have a Linux machine because you prefer Mac, you can do that as well. Now what I'm gonna do is I'm gonna switch back over here and we're gonna change the text size. And let's see if we'll get everything to show up with the text size of 3. So let me save that. And then we're gonna go ahead and we're gonna upload it. And when he says connecting, I'll go ahead and press the button. And once he writes, then I'll switch over here to the overhead view so we can see what's happening. So this should change and the text should get larger. So you guys see that?
Yes.
Okay, so that's examples of the 3 different size of text that you have. Now,